To talk about advances in smartphone-based body scanning and also show some use cases that we have been doing in the last few years. My name is Petri. I'm the CEO of Astrivis. So if you look at body scanning as a field, we see kind of that traditionally we have been using highly accurate, really great professional hardware scanners, but they cost a lot. Mobile phone solutions can be a filler. So here the goal is that we don't want to replace existing solutions. We want to offer new opportunities for more use cases out there. We have the traditional photogrammetry solutions, where basically which take input images of the model from different sites, and then you feed that into a highly complex program, and then it computes, runs hot, and then gives the result. But then the second group is basically mobile scanners that use active sensors. So they use either built-in sensors on the mobile phone, like the LiDAR or Face ID scanner, or attachment, like structure sensor. You're limited by the sensor, because that's the data that you're working with. Real-time mobile photogrammetry solutions basically try to get the benefit of both worlds. So only relying on image input, basically working on any smartphone that has a camera, which I would say every smartphone today has that, while trying to kind of provide this real-time feedback, which makes the scanning really nice. What this scan looks like in our solution. So you start pointing the phone to object that you want to scan. Then we start computing how the camera is moving with those yellow dots. And then already during scanning, you start seeing the point cloud appearing. That's already the 3D data. And this allows you kind of to see which parts you scanned, and makes it much more easier to kind of get a complete nice scan. And then once you're done, you can start compute the final surface of the model. And then on top of that, we add the texture from the camera images that we already have on top of the model. And like that, you get within seconds a complete 3D model on your phone without any cloud communication. That's a part which does the real-time reconstruction on the phone. The main reason why we started including a cloud solution also to our SDK was kind of that we noticed that getting the data off the phone is always a problem, and many customers want to have like an easy way of kind of download the data. So we offer cloud upload, and also the cloud allows us to offer the same cloud refinement than traditional photogrammetry solutions do. So we can just directly start refining the model. Some of the use cases that we have been doing in the last years. Let's start with foot scanning. So here, like one scanning approach that we propose always is kind of start it inside the foot and then do a simple circle towards the heel, allowing us to kind of get 360 scan data from the foot. Scanning is completed. Here we add also some additional models like cleanup that basically separates the foot. And then you can also optionally have the texture. And then once we have this model, we can also extract measurements. One example of ground truth comparison that we did. So on the left, we see a scan done with the Artec EVA HD sensor. We can see that mostly we see that the mobile quality that is computed on the phone is useful for most of the use cases. And then once we have the final model and we are sure it's good, we can extract measurements. And the second use case that we have been working on is leg scanning. This is now targeted to compression stocking use case. And here we basically start on the side, and the second person walks around the person on both sides, back and forth. We have a cleanup model, cleanup stage, where we separate the legs. So here, this approach, we do left and right leg separated, and here we separated the leg. We take the standard 9 or 5 circumference measurements, and this one is just repeatability plot, 5 scans for the same person, showing the circumference based on the height along the leg, basically. And the last use case that I want to show, the goal that we kind of get from the offline refined, cloud refined models that you see on the left. We want to kind of use a fitted face model to represent that. Usual problems are, of course, the face model doesn't really nicely fit the actual person because the parameter space is not really big. And these areas usually happens in the eyes, mouth, and the ears. And kind of like use the image information where we can extract certain landmarks and kind of like here, for example, the mouth line. We can basically then constrain the optimization such that then the final deformed mesh then basically perfectly fits the image where we texture from. And that ear case, so here we can also extract the outline of the ear and basically then also guide the optimization such that we get kind of matching geometry with the images. And so the final result here, in this case, for example, started from the raw face model mesh. We can get kind of like a slightly smoothed version of the cloud refined mesh at the end and with texture.